So we talked about how to find the slope between two different points on a graph on an x and y axis, and all we had to do was count the rise versus the run. Go up and go to the right or left for however far we went, and we just simplified that down. Now what if I gave you actually a set of points? Well, one way is you could just graph it on here and see what it is, but instead of doing all that tediousness, we actually can learn this formula here for rise over run. y2 minus y1 over x2 minus x1. That sounds a little bit weird, but all you're really doing is determining the change in the y's versus the change in the x's. Okay, and there's a symbol I want to make sure I kind of show you. This right here just means that's a delta symbol. It's like a triangle. It just means the change in y's divided by the changes in x's, which is really what rise over run is, right? The y's are the going ups and downs, that's the rise, right? And the x's are the lefts and rights, which are like the runs, okay? So that's essentially what slope is. Now, how we do that? Well, we just really just plug these numbers in. So this is a set of x and y coordinates. Remember, that's what x and y are. X's are all of your first numbers, and y's are all of your second numbers. These are ordered pairs, right? Now, it doesn't really matter which one you make your first set of ordered pairs versus your second. I'm just going to make these my first. So this is my x1 and y1. And this is my x2 and y2. And all we got to do is just literally just plug it in, and we get our answer for slope without even having to graph it. Isn't that easy? So let me write down the equation. y2 minus y1. Well, my y2 is 16. Take away my y1, which is 8, over x2 minus x1. So x2 is 9. Take away my x1, which is 20. Make sure no matter what you do, you stay consistent with how you label this. So my x1s and my y1s are here. My x2s and my y2s are here. Make sure you always do it like that. So all we have to do is simplify this down. So this will be 16 minus 8 is 8 over 9 minus 20, which is negative 11. Now, I'm not putting the negative there for a second because you can put the negative here, you can put it here, you can put it there. Since this is a fraction, I always like to have my negatives right here. It doesn't really matter where you put the negative because, again, it's still going to be a negative slope, right? So this means my rise over run is 8 over negative 11 or negative 8 over 11, whichever way you want to slice it, okay? So that means it has a negative slope, so it's falling. Now, what about this one over here? Let's do this one the same way. So x1, y1, x2, y2. Easy as that. Let's plug in the slope formula to see what kind of slope it has, okay? So again, I'm going to use the exact same formula over here. I'm just going to plug everything in. Negative 7 minus a negative 19. If you see two negatives, what I always do is always turn it into both positives, right? Because subtracting a negative is the same thing as adding a positive. So then I do on the bottom, x2 minus x1, x2 minus x1, and then I just see what that is. Negative 7 plus 19 is 12 over negative 2 minus 1 is negative 3. Now this you can simplify down. Now you could technically leave it as a rise of 12 over a run of negative 3, but let's simplify that down. 12 divided by negative 3, that's a lovely negative 4. So this one also has a negative slope. That's totally fine, okay? Now, we also talked about when we did slopes, we talked about anomalous ones. They're a little bit strange, okay? Let's do one like this. I'm going to give you a point, 19 comma 3, and then it's going to be 20 comma 3. Now notice the y's. Remember how I talked about slope is just the change in x's versus the change in y's. The y's didn't change. There's no rise here. What does that mean? We talked about that before, but let me prove to you what actually happens with this, okay? So I'm going to label my x1, y1, and my x2, y2, and I'm going to plug it in. So remember, y2 minus y1. So y2 is 3 minus y1, which is 3, over x2, which is 20, minus my x1, which is 19. And again, I'm just using this formula right here and plugging it in. Well, 3 minus 3 is 0. Over 20 minus 19 is 1. 0 divided by anything is always 0. This has a 0 slope. So it's like that slope we talked about where it was like just a flat line. That's what this one would look like, okay? That's this slope. Now, one more we're going to do. It's going to be kind of backwards of this one. So this one's going to have it like this. Let's actually just flip it around. Let's do 3, 20, and then 3, 19. So notice with this one right here, the x's don't change, but the y's do. What happens there? Again, x1, y1, x2, y2. Let's plug it into our formula and just see what happens, all right? So on the top, we have y2 minus y1, so that's 19, take away 20. And then on the bottom, we have x2 minus x1, took me a moment, 3 minus 3. Well, on the bottom is 0, on the top is negative 1. Whenever you have a 0 on the bottom, it can't work. Negative anything divided by 0, it's undefined. That's when we have that slope that kind of goes up and down, okay? So this is kind of the formula that we use instead of graphing. Now, you could always graph it if you want to on that little x and y axis we talked about, but this is easier if you have the point. So this is how you find the slope between 2 points if they give it to you just like this.